This conference will now be recorded.
In today's session, we'll try to discuss about what is Kubernetes and what are the advantages of Kubernetes and how to set up the Kubernetes cluster. We'll discuss. So as we already know, we have a containerization platforms and we have a container orchestration. So Docker so these are containerization tools using which we can build, we can ship, and we can run our applications as containers. Okay? To manage these containers, to scale and load balance these containers, okay, we will use container orchestration softwares like Docker Swarm, Kubernetes, OpenShift, Mesios, like this. So we already discussed what is Docker, how to create images, how to create containers, how to push and pull the images, volumes, networks, all those stuff we discussed in Docker. And also we discussed Docker Swarm, how to orchestrate the containers using Docker Swarm. Now, the most widely used container orchestration platform is now Kubernetes. The most widely used containerization platform nowadays, it's Kubernetes. So what is Kubernetes? In short form, we call it as a K8s, Kubernetes. So there are 8 characters. There are 8 characters in between K and S. So people call as K8s, Kubernetes. So Kubernetes it's an open source container orchestration platform. It's an open source container orchestration tool. So it's an open source container orchestration platform is used to manage the containers, right? Can we consider Kubernetes as a replacement for Docker? Can we consider Kubernetes as a replacement for Docker? Can we consider Kubernetes as a replacement for Docker? No. Kubernetes is not a replacement for Docker. But can we consider Kubernetes as a replacement for Docker Swarm? So we can consider Kubernetes as a replacement for Docker Swarm, container orchestration. So Kubernetes is an orchestration engine, container orchestration software. Most importantly, it's open source. What is the meaning of open source? It's a free. It's completely free, right? It's an open source platform for managing containerized applications, containers. Like any other container orchestration platform, what is the responsibilities of Kubernetes? The responsibilities of Kubernetes includes container deployment, deploying the containers, scaling or descaling the containers, and load balancing the containers. So like any other container orchestration, Kubernetes is responsible for managing the containers, scaling the containers, and load balancing the containers. Actually, Kubernetes is not a replacement for Docker. As I told, Kubernetes is not a replacement for Docker, but can be considered as replacement for Docker Swarm. Docker Swarm is pretty simple and straightforward. Docker Swarm is pretty simple and straightforward. It's not much complex compared to the Kubernetes, but Kubernetes is significantly complex than Swarm. It requires more work to deploy the applications in Kubernetes. In Docker Swarm, it's pretty simple. We can just create a service will manage the containers. But in Kubernetes, Kubernetes is slightly complex than Swarm. We need to create a lot of things in Kubernetes to deploy the applications. But Kubernetes cluster is very strong. Kubernetes cluster is very strong compared to the Docker Swarm. Kubernetes offers a lot of functionalities, lot of features compared to the Docker Swarm. So Kubernetes is written in Go language. Kubernetes is developed in one language called Go. Go language. So who developed Kubernetes initially? Initially, Kubernetes is developed by Google. Google developed this platform, Kubernetes platform, written in Go language. Kubernetes is developed by Google initially, written in Go language. If you take most of the applications in Google, like Gmail, YouTube, all those things are running as a containers, and they are using Kubernetes to orchestrate, manage those containers. So initially, Google developed Kubernetes for their internal use. Later, Google donated Kubernetes to one organization called CNCF. Google donated Kubernetes to one organization called CNCF, Cloud Native Computing Foundation, in 2014. So which means now who is managing Kubernetes? Who is owning and managing Kubernetes? CNCF, Cloud Native Computing Foundation. But initially developed by Google. So Kubernetes first version, Kubernetes 1.0, Kubernetes first version released to market in 2015. So Kubernetes is available for the people. Kubernetes is available for IT. From when? So from when people started using Kubernetes is people started using after 2015. So like almost close to 6 years now. So the current stable release is what? Version 1.22, which means how many releases has happened within Kubernetes? Version 1.0, version 1.22. So almost 22 releases has happened, major releases happened within Kubernetes. You can understand a lot of features, how many features they would have been added. So they have been added a lot of features within Kubernetes. Right? So Kubernetes is widely used. Why? Why it is widely used compared to other container orchestration softwares? Why it is so popular? Why it is widely used? One is, most important thing is open source. Second is brand. Kubernetes is branded by whom? It's a Google brand, right? And also community. Community. What is the meaning of community? There are plenty of people who is contributing or helping for Kubernetes. Like there are lot of people contributing for Kubernetes. Like if there are any issues, help, there are plenty of people from whom you can get a lot of help, right? So then it is widely used. Lot of people are using Kubernetes compared to the other container orchestration softwares. Okay. Now, what are the features? The features of Kubernetes. Scheduling. Scheduling. What is the meaning of scheduling? Here also, like what we are going to schedule, what we are going to deploy in this cluster, containers, right? So Kubernetes provides advanced scheduler to launch containers, to schedule the containers on the nodes. Kubernetes has automated scheduling. Kubernetes provides advanced scheduler to schedule the containers on the nodes based on their resource availability, based on their resource requirements and availability. Kubernetes schedule the containers to the nodes based on the resources like CPU, memory requirements as per the availability. Kubernetes will schedule the containers to the nodes based on the resource requirements and availability. Now, self-healing capabilities. Self-healing or self-recovery. So, Kubernetes will reschedule or recreate the containers if the container goes down. Kubernetes, will replace or reschedule the containers if container goes down or if node goes down. It will reschedule, recreate. Self-healing capabilities. And also, Kubernetes allow us to do the rollouts. Rollout in the sense deploying the latest code, deploying the latest images without downtime. Without downtime, we can deploy the latest code, latest images in Kubernetes. And also, if something goes wrong, we can roll back to the previous state, the previous deployment. Rollouts and rollbacks. And also Kubernetes supports a scaling. Kubernetes supports scaling and load balancing. Same as Docker Swarm. What is the meaning of scaling? What is the meaning of scaling? Increasing and decreasing the number of replicas as per the requirement, as per the load. But here Kubernetes supports manual scaling as well as auto scaling. Auto scaling. Kubernetes supports manual scaling as well as auto scaling. Auto scaling based on the CPU, based on the memory, based on the load on that application, based on the CPU utilization, based on the memory utilization. Kubernetes can increase and decrease the number of pods. Here we call it as a pod. We will discuss what is pod later. So it will increase and it will decrease the number of pods, number of containers manually, or we can do the auto scaling. And again, if we have a multiple replicas, multiple containers for that application, can we do the load balancing within the cluster? Within this cluster, the way we have done, the way it works in Docker Swarm also, here also it does the load balancing if there are multiple replicas, multiple containers. Then service discovery and load balancing. Service discovery and load balancing. Sometimes in the interview also they will ask, what is service discovery? Service discovery is like a design pattern, one design pattern, right? One design pattern. We no need to worry about where exactly that service, that application is running. You no need to depend on where exactly, in which machine it is running, right? So we can just use names, kind of a DNS names, without worrying about where exactly it is running, in which node it is running in the cluster, what is the IP of that node, or what is the IP of that container. We no need to worry. So we can use service discovery. There will be a design pattern. There is a design pattern that is implemented in a Kubernetes. So we no need to worry about networking and communication. We no need to worry about networking and communication, which means what is the IP of that container, where exactly it is running, and how to communicate. We no need to worry, because Kubernetes will automatically assign IP address to the containers. IP address to the containers. Basically, here we call it as a pods. IP address to the pods. Then a DNS name, basically service name, DNS name for those pods, containers. Then we can use that name, service name, DNS name, that can load balance the traffic inside the cluster. So do we need to depend on the IP addresses? IP addresses are dynamic. If pod goes down and recreated, IP will change. We no need to depend. So there is a inbuilt service discovery, DNS, and it also does the load balancing. If there are multiple replicas for that service, it does the load balancing. Kubernetes has a service discovery and load balancing embedded in Kubernetes. Now, storage, volumes, right? So Kubernetes is again managing what? Kubernetes is again managing or orchestrating what? Containers. So if container goes down, whatever data which is generated inside the container file system, do we have the data if the container is deleted and recreated? Do we have the data if the container is deleted, recreated? No, right? So we need to use a volumes concept. We need to use a volumes concept. Kubernetes also, in Kubernetes also, you can mount the storage of your choice. You can use local storage, local volumes, or you can use cloud storage like EBS, EFS, S3, or NFS. You can mount whatever storage of your choice with your containers in Kubernetes to maintain the state. So before we go for installing Kubernetes cluster, before we set up the Kubernetes cluster, we need to understand this Kubernetes architecture. It's very, very important. Sometimes in the interview, there might be a lot of questions you get on the Kubernetes architecture. So it's very, very important to understand the architecture before we set up the Kubernetes cluster. So Kubernetes again implements a cluster background. What is the meaning of cluster? Again, Kubernetes implements a cluster background, cluster computing background. What is the meaning of cluster? Again, cluster is nothing but group. cluster, group. So Kubernetes cluster, group of Kubernetes machines, servers. So again here we will have a master, we will have a workers. Here again we will have a masters, we will have a workers. So everything works inside a Kubernetes cluster. This cluster is hosted by masters and workers. We will have a master nodes, we will have a worker nodes. Okay. So again it's a cluster. We have a group of servers where we have a masters, we have a workers. Now Kubernetes is container orchestration software. Container orchestration software. So in each and every server in the Kubernetes cluster, what software we need to have? Suppose I want to set up one cluster. So I have one, I have set up, I want to set up some servers. What software is required in each and every server? Kubernetes is a container orchestration software. So what software is required? In each and every node, you need to have a container runtime. Let's say this is one server. This is another server. This is another server. So in each and every server, we need to have a container runtime, containerization runtime, container runtime or containerization runtime. So what are the container runtimes? Can I call Docker as a container runtime? In each and every server, we need to have a containerization runtime or container runtime. In each and every server, you need to have a container runtime, even in the master also. Even in the master also, you will have that container runtime here. So Docker supports lot of containerization runtimes. Not only just Kubernetes supports lot of container runtimes. No, not only just Docker. So using Kubernetes, I can orchestrate Docker containers, or I can orchestrate CoreOS containers or CRIO. Okay, this is all containerizations, container runtimes like Rocket, Containerd, CoreOS, CRIO. All these things we call it as a containerization runtimes or container runtimes. Docker, Rocket, Containerd, CoreOS, all these are containerization tools or container runtimes. So using Kubernetes, I can orchestrate Docker containers, I can orchestrate CoreOS, I can orchestrate CIRO containers, or I can orchestrate Rocket containers, which means does Kubernetes supports these containerization tools, or it supports only Docker? It supports all the containerization runtimes. So in each and every server, you need to have a container runtime. What is that container runtime? That can be Docker, that can be CRIO, that can be CoreOS, that can be Rocket, container runtimes. Actually, if you ask me, Docker is not a containerization software. As I already told, I think in the beginning itself, I told Docker is not actually containerization runtime or containerization software. So Docker is internally using Docker is internally using container D. So Docker has a lot of Docker has very good CLI and APIs. Docker has a very good CLI. What is CLI? Command line interface, and APIs, application programming interface, to manage, create, manage images, containers. But Docker is internally using container D as a runtime. Docker is not actually a containerization runtime, it's a wrapper of lot of features. So I'm not sure whether you heard or not. Kubernetes is deprecating Docker. Kubernetes is deprecating Docker. Did you guys heard about this news? Kubernetes is deprecating Docker. So what is the meaning of it? Kubernetes is deprecating Docker. Why it is deprecating Docker? What is the meaning of deprecating? Kubernetes is going to no longer support. Kubernetes is going to no longer support Docker as what? Kubernetes is going to be no longer support Docker as a container runtime. Why? Why it is no longer supporting? Why it is deprecating? Because Kubernetes has to have a lot of additional overhead, lot of additional modules, packages to support Docker as a container runtime. As I already told, Docker is internally using what? What container runtime it is internally using actually? Container D. Container D. So if Kubernetes can support a directly container D, why they need to have a additional support, additional overhead to support Docker? If Kubernetes can directly support container D, why they need to have additional overhead, additional support for Docker? Because internally Docker is using what? Container D. So that's why Kubernetes is deprecating Docker. Does it mean it's end of Docker? Does it mean it's end of Docker, or still Docker can be used? Even though we are using Kubernetes, if Kubernetes is no longer supporting Docker, does it mean it's end of Docker? No. So we can still use Docker. We can still use Docker. For what? We can still use Docker to create images. To create images. So all the containerization, all the containerization are following some standards. All the containerization is following some standards. We call it as an Open Container Initiative, OCI. So we call it as a OCI. All the containerization tools are following OCI. So OCI in the sense Open Container Initiative. Open Container Initiative. Like all are following same standards. Open Container Initiative. So it's a standard. Open Container Initiative is a open governance structure for creating industry standards around container formats and runtimes. So Open Container Initiative is established 2015. So Docker and other leaders in the container industry like Containerd, CoreOS, Rocket, right? So all are following the same specifications, which means If I create images, that container images using Docker, will I able to run those container images in Rocket container runtime, containerd container runtime? If they are following some standards, right? OCI, Open Container Initiative. OCI, we call it as a Open Container Initiative, is a governance. It's a governance formed to manage the standard structures, standard specifications around the container runtimes and its layers. So, which means Docker has a very good CLI, very good API. Even though Kubernetes is not supporting Docker as a runtime, can I use Docker to still create images using Docker? And can I use Docker registries? I mean to say registries to maintain, push and pull the images. Still Docker is powerful. Docker is still powerful. Docker is still powerful tool when it comes to building the images and maintaining the images compared to others. Even though Kubernetes is deprecating Docker, we can still use Docker for only building the images and pushing and pulling the images. Those images, if I want to deploy and manage using Kubernetes, if Kubernetes is not supporting Docker, can I use containerd as a runtime in Kubernetes? Can I still deploy images which is built using Docker? Yes. So it's not end of Docker. It's not end of Docker. Even though Kubernetes is deprecating Docker after 1.22, which means it is already deprecated. So Kubernetes is deprecating Docker after this version. Even though Kubernetes is deprecating Docker, which doesn't mean it's end of Docker. We can still use Docker for creating images, maintaining the images. Those images we can deploy on a containerd runtime or other runtime also. Okay. If you see Kubernetes deprecating Docker in the official website itself, you can see. This is the official website of Kubernetes, kubernetes.io. Kubernetes.io. This is the official website of Kubernetes. This is official website of Kubernetes. So here itself, you can see Kubernetes is deprecating Docker as a container runtime after 1.20. Okay. So you no need to panic. There itself, Kubernetes itself, it is saying, don't be panic by hearing this news. It is not as panic as it sounds, which means, so Kubernetes is deprecating Docker as the underlying runtime because that uses containerd internally. So why they need to have additional support for Docker if internally again they are using containerd? That's why they are deprecating Docker. But still we can use Docker. I have I have created one detailed video in our YouTube channel where I have explained why Kubernetes is deprecating Docker. This video, I have explained in detail why Kubernetes is deprecating Docker and what is the future of Docker. What is the future of Docker? Does it mean it's end of Docker or still we can use Docker? So I have explained in this video in detail. I strongly recommend you to go through this video because sometimes in the interview they will ask, so Kubernetes is deprecating Docker. What does it mean? Why they are deprecating Docker? Does it mean it's end of Docker? Can't we use Docker? All those things I have explained in this video. And also in this video, I explained how to set up a Kubernetes cluster. How to set up a Kubernetes cluster using containerd as a runtime. As a containerd as a runtime instead of Docker. Right? I strongly recommend you to go through this video, which is there in our YouTube channel. Okay. Why Kubernetes is deprecating Docker? What is the reason behind that? And what is the future of Docker? We discussed in detail in this video. But as I already explained, even though Docker doesn't support, even though Kubernetes doesn't support Docker, can we still use Docker? Can I still use Docker images and deploy those Docker images in Kubernetes if they are using different containerization runtime? Yes. So Docker is still powerful when it comes to creating and managing the images. Now, if the Kubernetes is deprecating Docker, now instead of Docker, can I have containerd as a runtime? Now Kubernetes is not supporting Docker, it is deprecating. So instead of Docker, can I have containerd as a container runtime instead of Docker here? Yes, no. Docker is deprecated. I mean to say Kubernetes deprecated Docker. So instead of Docker, can I have containerd software installed here? Yes, right? So they deprecated in the sense it is going to work. It is going to work, but it is been deprecated, which means if there are any issues comes, they are not going to support, right? But it is deprecated after 1.20, which means in your company, if you are still using Docker 1.19, 1.18, can I still use Docker as a container runtime? Suppose if we are still using these versions of Docker, so Kubernetes, these versions of Kubernetes, can I still have a Docker as a runtime? Yes. In 1.20 plus also we can have. I mean to say here also we can have. Here also we can still use Docker. In 1.20.2 also we can use. But it is deprecated, which means if any issues arises in these versions of Kubernetes, if you are using Docker, do you get any support, any help? They are not going to support around this, right? They are not going to make any changes, any fixes in their Kubernetes software if there are any issues around Docker. So that's why instead of Docker, we can use different container runtime like containerd. Now, instead of Docker, I will be using containerd as a container runtime. So in each and every machine, what software is required? As I told, if I want to set up a Kubernetes container runtime, that can be containerd now. Then we will have some Kubernetes related. Now instead of Docker, we will be having containerd. We will be using containerd here, containerd here, containerd here. So in Kubernetes, are we going to execute any Docker commands like Docker run, Docker service create, Docker PS? No. All are Kubernetes commands. All are Kubernetes commands. kubectl commands. All are kubectl commands, Kubernetes commands. We are not going to use Docker commands. And also, if you go inside that server, if I go inside that server, you can't execute Docker PS because you have not installed Docker. If you install Docker, you can execute Docker commands, but if you install containerd, you can't use Docker commands. And again, we are not going to use Docker or containerd commands. We are going to manage everything using Kubernetes commands. So that way, does it matter whether we are using Docker here, whether we are using containerd here? Does it matter? Does Kubernetes commands will change based on the container runtime? Does Kubernetes concept will change? Does Kubernetes commands will change based on whatever container runtime you are using? No. Kubernetes commands, Kubernetes concept remains same. Whether you use Docker, whether you use containerd or other, that doesn't matter. Kubernetes concept remains same. So Kubernetes is going to use this runtime to create and manage the container. That's it. Kubernetes is going to use this runtime, container runtime, to create and manage the containers. Now, we have some components, Kubernetes related components in each and every machine. So, in master machine, we will have some components. What are the components you see in the master? Important components. We have some components. In the master, we have few components in the worker. Architecture is very, very important. In the interview also they will ask. So in the master, these are the important components. We call it as a Kubernetes master, or we call it as a Kubernetes control plane. We call it as a control plane or master. So in master, we have few components like this. API server, control managers, scheduler, we have a etcd. These are in the master. This we call it as a master node or control plane. So in Kubernetes cluster, who is responsible for orchestrating, managing, controlling? This control plane, this master. So within this master, you have some components like this: API server, scheduler, etcd, control manager. Now, if I want to deploy or update or delete applications in this Kubernetes cluster, whom should we contact? Whom should we contact? If I want to deploy, update, delete the applications in this cluster, Kubernetes cluster, whom should we contact? Master. So within this master, we have some components. So how can we interact with master? How can we interact with master, that control plane? We can use CLI, or we can use GUI also. What is the meaning of GUI? GUI, dashboard, Kubernetes dashboard, UI, dashboard. CLI. What is the meaning of CLI? Command line interface. What is the command line interface? What command line interface Kubernetes we will use? There is a command line interface called kubectl or kubectl. So I can interact with my Kubernetes cluster using CLI or GUI. But for automation, we are not going to use GUI. We are going to use what? For building, deploying, all those things, we are going to use CLI only. Now kubectl or GUI. So any request to the Kubernetes first goes to any request to the Kubernetes, whether you want to delete, whether you want to update, whether you want to deploy application in Kubernetes, we are going to interact with master. But the request goes to what first? Any Kubernetes command I am executing. Let's say I am executing kubectl run something like this. I am using this image. Using this image, I am trying to deploy. So any request or any command you execute, the client, the Kubernetes client, I call it as a Kubernetes client. The request goes to what first? In the Kubernetes master, what is the main component in the master? Basically, this API server. API server. What is the meaning of API? What is the meaning of API? In control plane, in master, you will have a API server. What is the meaning of API in general? Application programming interface. So as I already told, Kubernetes is developed using some programmatic language. Kubernetes is developed using some programmatic language. Which programmatic language Kubernetes is developed? Go language. So everything is implemented as an API. Whatever we do in Kubernetes is actually an API. We are making a API calls. But these APIs are developed using some programmatic language. Does it mean, do we need to learn that programmatic language to deploy the applications in Kubernetes? Not required. So whenever we are executing that command, in the background, what is happening? It is making, in the background, it is making a API calls. It is making API calls. That API calls will be processed by whom? In the control plane, in the master. Who will receive that API call? Who will validate that request? And who will process that request? This API server. This API server. I am requesting you, using this command, I am requesting to create a pod or container. So first request goes to that API server. It will validate that request. If the request is proper, then it will process that request. So we have a API server in the control plane. So any request to the Kubernetes will be processed by who? It will receive, validate that request and process that request. That will be done by API server. Okay. So you have a API server. So API server interacts with API. It's a front end kind of, it's kind of a front end for Kubernetes control plane. Communication center for developers, DevOps guys, and other Kubernetes components. So if I want to deploy something, if I want to delete something, if I want to update something in Kubernetes, the request will go via API server. It's kind of a front end for Kubernetes control plane. Now, I'm requesting Kubernetes to create a pod using the CLI. So first request goes to whom? Request goes to API server. This API server. Now, what this API server does? This API server will validate, it will process, it will validate. API server validates the request, whether it is correct or not. Then once this is done, what API server does? That API server will persist that information in etcd. That API server will persist that information in etcd. API server persists. What is the meaning of persist? That information, the details in etcd. So this API server validate that request. If the request is valid, then that API server persists that details, that request, that information in etcd. So what is etcd now? Guys, all these are interview questions. Definitely they are going to ask, can you explain Kubernetes architecture? What are there in master machine? They may directly ask, what is API server? What is etcd? Or they may explain, they may ask you to explain, can you explain the Kubernetes architecture? So any request to the Kubernetes cluster will process by API server. It will validate and process that request. API server persists those details into the etcd. So what is etcd now? So etcd, it's a database. It's kind of a database. It's a key value distributed data source. Database. It's a key value database, key value distributed data store. So it's a database. etcd is kind of a data source, database. But is it a database for our applications which we are going to deploy, or it's a database for Kubernetes? So this etcd, is it like a database for the applications which we are deploying in that cluster, or it's a kind of a database for Kubernetes itself? So it's a database for Kubernetes. Database for Kubernetes. Pronounced as etcd. There is no full form for that. etcd. Pronounced as etcd. There is no full form for that. Okay. It is pronounced as etcd. So it's a database for Kubernetes. What kind of information Kubernetes will maintain in this database? It will maintain nodes information, like how many nodes are there, pods information, how many pods are there. I will explain what is pods later. Deployments information, services information, config maps information. It's kind of a database for Kubernetes, right? It is going to maintain some information in this etcd. So etcd is a data store. Kubernetes will use etcd as its database to store some of the information, like pods information, nodes information, all those details, cluster information in a etcd. Then we have one more component called scheduler. What this scheduler is responsible for? What this scheduler is responsible for? The name itself is saying scheduler. What it is going to schedule? It is going to schedule what? It is responsible for scheduling the containers, your applications in the cluster. So this scheduler is responsible for scheduling the application, scheduling the containers. But in Kubernetes, Kubernetes will not manage the containers directly. Kubernetes, there is a concept called pods. I will come to that. So what that scheduler does, scheduler will try to schedule unscheduled pods. The scheduler will find from etcd, the scheduler will try to find the scheduler. What it does, let me maybe keep here. So scheduler will find unscheduled pods, if any, from etcd. Then it will assign basically nodes to that pods. So scheduler is responsible for assigning nodes, in which node that pod has to be created. The scheduler is responsible for scheduling the pods. So the scheduler is responsible for scheduling the pods with the help of what? So the scheduler is responsible for scheduling those pods to the nodes. So the scheduler will interact with whom? Or this master machine will interact with whom? In the worker machines, to schedule the containers and to manage those containers. So in the worker machine, we have one more component. We have a few more components in the worker machines. What is that components here? If you see, there is a component called kubelet. So this master machine will interact with whom in the worker machines to schedule the containers and manage those containers? The worker machine will have one component called kubelet. Don't get confused with kubectl and kubelet, guys. Kubectl is what? Don't get confused with kubectl and kubelet. Kubectl is what? CLI. This kubelet is what? Kubelet is basically a node agent. Kubelet is basically a node agent, primary node agent. So master will be communicating with kubelet to manage node and pods which is running in that node. So the master machine will communicate with whom? To manage pods, to manage node and pods which is running in that node. The master machine will communicate with whom? To check whether whatever pods I have scheduled, whether it is running or not. Can I still schedule some other pods in that node? So master machine will communicate with whom in the worker machines to manage the pods and nodes? Kubelet. So do we have a kubelet in each and every node? Do we need to have a kubelet in each and every node in that cluster? In fact, in the master machine also, this is also one node. In fact, in the master machine also you will have a kubelet. But in an architecture perspective, this is not important in the master. So master is also one node. We call it as a master node. So in this node also you will have a kubelet, but at architecture perspective, this is not important in the master. So The master machine will communicate with whom to manage the pods and nodes? Kubelet. So the scheduler will communicate with kubelet and assign the pod. What this kubelet does? That kubelet will fire a container command. The kubelet will interact with this container runtime. It will fire a container commands to pull the images and create the containers. This kubelet will fire container commands to pull the images and create the containers in that node. We have a kubelets. The master machine will use kubelet as an agent to manage the pods and nodes in the cluster. Now, we have a control managers. We have a control managers. We have a control managers. We have a lot of control managers like node control manager, and service control manager, replica control manager. The name itself is saying control managers. Is it going to control something? If something went wrong in the cluster, is it responsible for controlling? We have a lot of control managers like this. Control managers runs as a controllers in the background, which will run different tasks like replicating, keeping a track of worker nodes, handling the node failures, like this. We have a different control managers like node controller, replication controller, like this. So what node controller does? It is responsible for noticing and responding when node goes down. Suppose one of the node goes down, there will be a node control manager. What that node control manager does? It is going to take some action. What action that node control manager takes if that node goes down? Is it going to reschedule the pods which is running in that node? Is it going to reschedule those pods to other nodes? Yes. Similarly, we have a replication controller. So it has created a pods. We created a pods using Kubernetes. We created a replicas. So I requested 2 pods. If something went wrong with this pod replicas, does that replication controller, does the replication controller will see whether we have the given number of pods in the cluster? If it is not matching with the desired with current, does this replication controller is responsible for again recreating that pod? Like this, we have some controllers which is going to do some tasks in the background, managing the pods, managing the node failures, like this. So in the master perspective, these are very important: API server, control manager, scheduler, and etcd. So what is kubelet? Kubelet is a worker node worker component. It's kind of a node agent. So this master machine, this control plane, will manage the node and the pods which is running in that node, with the help of whom the pods and the node and the pods which is running in this node will be managed with the help of whom? By this master, using kubelet. So kubelet, as I already told, kubelet is the primary node agent that runs on each and every node. So which will follow the instructions given by master, and it will make sure that containers are running in a pod. Okay. So we have a master node, we have a worker node. So worker nodes are the nodes where application is actually running in Kubernetes. So by default, our pods, whatever containers we are going to create, those containers will not be scheduled in the master by default in Kubernetes. So where the applications will be running in Kubernetes by default? In the master, does our pods will be created? Does our application will be scheduled in the master by default? No. It will be only in the workers. So we call it these as a worker nodes or slaves, or sometimes we call it as minion. All are same. Kubernetes worker node, Kubernetes slave, Kubernetes minion, all are same. So these nodes are controlled by master using what? As I already told, these nodes are controlled by master node using what? Using what? It will control by that master? The kubelet, the agent. Now we have one more component. We have one more component called kuproxy. We have one more component called kuproxy. Guys, you can understand the importance of architecture. Why I am taking this much time to explain. It is very, very important. Interview standpoint, and also understanding how Kubernetes works in the background. So there is a one more component called kuproxy. What is this kuproxy? Kuproxy, it's basically a network proxy, which is responsible, this is responsible for routing the traffic to the pods, right? So kuproxy, we have a kuproxy, right? Kuproxy is a network proxy. It will maintain the network rules. So these network rules allow network communication to your pods. I mean to say your applications. If I want to access that application which is running in Kubernetes, right, within the cluster or from outside the cluster, that will happen via kuproxy. So kuproxy abstract the networking. Kuproxy enable Kubernetes service abstraction. So it will perform the connection forwarding. Kuproxy is a network proxy, right? It will help us to have a proxy and load balance the request within the cluster. It's a network proxy. Now, if I want to access application within the cluster or outside the cluster, in the background, request will be processed by whom? Suppose I want to access this application which I am running here from outside the cluster or inside the cluster. The request will be processed by whom? The request will be processed by that kuproxy. This proxy will help us to access the application which is running in the Kubernetes within the cluster or outside the cluster. Architecture is very, very important. Are you guys clear now? What is kubectl, CLI? What is all these things? And what is kubelet? And what is kuproxy? Is everyone clear on the architecture? Architecture is very, very important in the interview perspective. Suppose if you might have already attended the interview, definitely you might have got lot of questions on this Kubernetes architecture. I think Rajkumar, he is only attending Kubernetes and Docker. He is already working on DevOps, I think. He might have already attended the interviews, right? Did you got lot of questions on this architecture, Rajkumar? If you are already attended, So sometimes in the interview, they may simply ask, can you explain Kubernetes architecture? So in that case, you can tell Kubernetes is a master slave architecture. In master, I have a API server, scheduler, control manager, etcd. In the worker side, we will have a kubelet, kube proxy, and container runtime. Then we have a CLI, kubectl. Any request via CLI or UI, request goes to API server. API server will process that request. I told here, API server will process that request. That details will be maintained in etcd. Scheduler is responsible for scheduling the pods. Control managers are doing some background tasks. Kubelet is an agent. Kube proxy is a network proxy. This much is sufficient, right? So this is very, very important. Now let's try to come to the installation part, setup part. How to set up Kubernetes cluster. There are different ways to set up Kubernetes. There are plenty of ways we can set up the Kubernetes cluster. But primarily, there are two types of Kubernetes clusters. Self-managed Kubernetes clusters and managed Kubernetes clusters. There are different ways. There are plenty of ways we can set up the cluster. Self-managed Kubernetes clusters, primarily managed Kubernetes cluster. The name itself is saying managed Kubernetes cluster and self-managed. If I'm going to use self-managed, who is responsible for setting up the cluster, installing the required software, setting up the cluster, and making sure that your cluster is up and running? If I use self-managed, who is responsible for managing the control plane, installing and setting up? We are responsible for installing. We are responsible for installing, managing the cluster. If something goes wrong with your control plane, your master or your workers, will it be recovered? Will it be restored automatically? If I go for a self-managed Kubernetes clusters, if something goes wrong with your master or your worker, are you going to get another worker? Are you going to get another master if master goes down? If I use self-managed Kubernetes clusters? No. If I go for a managed Kubernetes clusters, am I responsible for installing, managing the cluster? No. The provider is responsible for that. So we have a lot of managed Kubernetes clusters. What are those? EKS, AKS, GKE, IKE. What is this? All these things. What is EKS? Elastic Kubernetes service. Elastic Kubernetes service in AWS cloud. So the way I created a EC2, I can create a EKS. In that case, who is responsible for installing Kubernetes cluster and who is responsible for managing that control plane, high availability of that control plane, that master and workers? If something goes wrong with your master, if I created a EKS cluster, if something goes wrong with your control plane, master, or if something goes wrong with worker, do I need to worry, or it will be replaced, recreated by that provider? If I go for a managed Kubernetes cluster, we no need to worry. The complete setup will be taken care by the provider, AWS. So what is AKS? What is AKS? Azure Kubernetes Service. So which cloud? Which cloud? AKS? Azure cloud, right? So GKE. What is GKE? Google Kubernetes Engine. Which cloud? Google Cloud. Like this, you have a IKE. What is IKE? IBM Kubernetes Engine. Which cloud? IBM Cloud, right? So like this, we have a managed Kubernetes clusters. Can I call this as a platform as a service? Kubernetes platform, PaaS. Kubernetes platform as a service. So in that case, do I need to manage, do I need to manage the infrastructure and that software, or provider will take care? If I go for these things, the provider will take care. Now, what is the responsibility as a DevOps engineer? If I am using EKS, we are just responsible for creating a service. I mean to say creating a EKS. Just we are creating a EKS. Then what is responsible? We are just responsible for deploying applications and managing its data. Do I need to set up? Do I need to install? Do I need to manage that control plane? I mean to say, if something goes wrong with this control plane, if anything happens with this control plane, do I need to worry? If something goes wrong with master, your API server, etcd is having some issue, do we need to worry? If I go for this managed clusters, no. So who is going to replace or recreate? Who is going to take care about high availability of your control planes? The respective provider. So this is managed Kubernetes cluster. Similarly, we can set up self-managed Kubernetes clusters. In case of self-managed Kubernetes cluster, who is responsible for setting up that control plane, setting up that workers? If something goes wrong with your workers, your masters, do we need to recreate or fix those issues? We, right? So we can set up self-managed Kubernetes using some softwares like this. We can use Minikube. We can use Kubernetes. We can use Cube Spray. We have some softwares. Using this, we can set up the self-managed Kubernetes clusters. Now, Minikube. Minikube is a single node Kubernetes cluster. Minikube is a single node Kubernetes cluster. Single node, only one node. In real time, are we going to use Minikube for a dev environment, production environment, QA environment, or it is only for local development? Like as a developer, you want to practice Kubernetes, or as a DevOps guy, you want to do some POCs in Kubernetes, I can install Minikube in my laptop. It's a single node Kubernetes cluster. But in production environment, are we going to use single node Kubernetes clusters? Only just one node? No. We can set up Kubernetes clusters using some other softwares like this, Kubernetes or kubeproxy. So we can set up multi-node Kubernetes cluster using Kubernetes. So whether it's a Minikube, whether it's a Kubernetes, whether it's a EKS, AKS, GKE, IKE, does Kubernetes concept will change? Whatever we are going to discuss, or whatever we already discussed and whatever we are going to discuss in the future, Does Kubernetes concept will change? No. Kubernetes remains Kubernetes, whether it's a mini kube, whether it's a kubedium, whether it's a kube proxy, sorry, this EKS, whatever it is, right? Now, at high level, there are two things: self-managed Kubernetes clusters and managed Kubernetes clusters. Okay? So, which one we will use in real time? That depends on what? Which one we will use in real time? That depends on what? Suppose if your client is not at all using infrastructure in AWS, he is not at all using cloud-based infrastructure. He is not using any cloud like AWS or Azure or Google or IBM cloud. Your client is not ready to use and he don't want to use cloud-based infrastructure. He still want to use Kubernetes. In that case, can I go for these kind of clusters? If he don't want to have his infrastructure, his applications hosted in the cloud, then can I go for these Kubernetes clusters if he still wants to use Kubernetes? If your client is not at all ready to go with cloud, he don't want his applications to be running in the cloud, he don't want his applications to be deployed in the cloud-based infrastructure like AWS, Azure. In that case, can I go for this managed Kubernetes cluster if client is not at all ready to have infrastructure in the cloud? No. In that case, can I set up self-managed Kubernetes clusters on his own data center servers? He has his own data center servers. He might be using his own data center using vSphere or VMware. He is doing the virtualization. He's in his own data center. So in that case, can I go for self-managed Kubernetes clusters? Can I create a servers in his own data center, virtual machines? Can I set up Kubernetes on his own virtual machines in data center using self-managed? Yes. But if your client is ready to use cloud-based infrastructure, if your client is okay to have applications hosted in the cloud, then which one you recommend? Do you recommend to create a EC2 instances and set up the cluster on your own using Kubedium, self-managed, or do you recommend this type of services? Which one you will recommend? Now, given a chance, your client is okay to have an infrastructure in AWS. So, are you going to set up the clusters yourself by just creating a EC2 instances and installing Kubernetes using this type of softwares? Or you will suggest this one, managed, completely managed? We can go with completely managed. So in that case, if I go for a managed Kubernetes cluster, do I need to have an overhead of installing the Kubernetes softwares, container runtimes, initializing the masters, initializing the workers, and taking care of high availability of masters? In that case, do I need to worry about all those things if I go for managed? No. We can just focus on deploying the applications in that cluster. So in case of self-managed, you need to take a responsibility of installing the softwares, Kubernetes softwares, setting up the softwares, masters, workers. If something goes wrong with master, you need to take care. So Kubernetes is just going to manage the pods. If your master goes down, your worker goes down, does Kubernetes will create another machine, another master, or another worker automatically? If something goes wrong with your master machine, if something goes wrong with your worker machine, does Kubernetes will recreate another master or another worker? Kubernetes, does it does those activities? No, Kubernetes is not going to manage the machines. Kubernetes, maximum what Kubernetes does? What maximum Kubernetes does? Let's say I have some applications deployed in this machine. Some pods are running in this machine. If this pods, I mean to say, if this node goes down, max Kubernetes, what Kubernetes does maximum? Is it going to create another machine automatically? No. What maximum Kubernetes can does? Kubernetes maybe move these pods to other nodes. It is not going to create this machine automatically. Similarly, if something goes wrong with master, are you going to get a master automatically? Does Kubernetes will handle the node failures, control plane failures? No. But if I go for a managed Kubernetes cluster, that provider is managing the infrastructure also, not Kubernetes. The provider. If something goes wrong with this node, if I am using EKS, who is the provider? AWS. If something goes wrong with this node, am I going to get another node? That will be taken care by the provider, AWS. AWS will create one more server for your worker. If something goes wrong with your control plane, does Kubernetes will create another control plane? I mean to say another master. AWS, not Kubernetes, AWS. Does AWS manages the nodes, that infrastructure in the background? Yes, right? So we will discuss how it will work when we go for an EKS. When we go for an EKS, how it works, how to set up the EKS cluster, we will discuss later. First, I will explain self-managed Kubernetes cluster using KubeDM. We are going to set up a Kubernetes cluster. What type of Kubernetes cluster? Self-managed Kubernetes cluster using KubeDM. So KubeDM, we can set up multi-node Kubernetes cluster. Now, we don't have any data center. Can I create a virtual machines in AWS? Can I set up self-managed Kubernetes cluster using KubeDM? I don't have any data center. Can I create a EC2 instances, virtual machines? Can I set up that cluster using this self-managed? Right? We can do that. So I will set up this self-managed Kubernetes cluster in the next class. It will take some time. Okay. But I strongly recommend you to go through this video. In this video, I have explained why Kubernetes is, why Kubernetes is deprecating Darken and how to set up a Kubernetes cluster using KubeDM. So we can set up using self-managed. Either you can do manually or you can use Ansible also. But setting up the cluster, is it like every time you are going to do whenever there is a change, or it's one-time activity? Do I really need to have a pipeline to set up the cluster? Do I really need to have a pipeline like a Jenkins pipeline to set up the cluster? Not required, right? It's like just one-time activity. But if you, that one-time activity also you can automate. I'm not saying we will not have a pipeline. That one-time activity also you can automate. But most of the cases, that will be provisioned manually, or that can be provisioned using Ansible. Or if I am using EKS, will I able to provision EKS cluster using Terraform script? Will I able to create EKS cluster using Terraform script, infrastructure as a code? you can provision that using infrastructure as a code. If you wanted to have it as a pipeline also, you can have, but very rare. So go through this video, guys. We'll continue on Monday. I will set up the cluster, self-managed Kubernetes cluster using Kubernetes. We will understand all the Kubernetes concepts. Later, I will set up the EKS also. I will explain what is EKS and how to set up the EKS cluster. Okay. Thank you, guys. That's it for my side. I'll continue on Monday. Try to practice, try to do the assignments, whatever has been pending. Okay. Today and tomorrow, utilize the time. Don't have any backlogs for Monday. Don't come to backlogs. Don't come with backlogs on Monday class, because you have to focus only on Kubernetes. Kubernetes is very, very important, and it is little complex also. We'll continue on Monday. Terraform we are not, it is not included as part of this detailed Terraform class, is not part of this DevOps course. That is a separate course. Maybe kindly contact admin team when that AWS, complete AWS and Terraform batch is going to be started. I don't have the details. Okay, you can contact admin team to get the details. Okay, guys, thank you. Have a great weekend. Come back on Monday. By completing all the assignments and all the pending tasks, we'll focus on Kubernetes from Monday. Thank you.
Okay. Happy weekend, sir.